Y'all can chat or speak up, my remote students, and you guys know what to do. Okay, so 13.2. So we started unit 13, rational functions, with just some introduction, previewing material of factoring, because as I said, you're going to need to know how to use the skill of factoring, or be refreshed in that skill, because you will be applying factoring in our sketching and breaking down of our rational functions in order to determine certain features and whatnot. So today in particular, we're not going to need to use the factoring skill, but we will by Friday. So that should work out okay, because I know people are still finalizing their factoring homework, which is due tonight. Okay, so that's my reminder to you as well, to get that done. Today's lesson is pretty much a warm-up lesson, or more of an introductory lesson as well, to rational functions. You are going to be introduced to two different forms of writing rational functions, and of course we're going to start with the more basic one, and the more basic one is written in this format right here. So y equals a, it's hard to see on your note-taking guide, but that is a division symbol or a fraction bar. Okay, y equals a over x minus h plus k, where our horizontal movement, just like we've done in the past, okay, where our horizontal movement is always going to be the quantity, obviously, next to the x, okay? And as you recall, with horizontal movement, we always do opposite of what that numerical value tells us to do, okay? So adding means you're going to the right, subtracting means you're going to the left, but you always do opposite of whatever that sign is. The number that's adding or subtracting on the outside of your function is still considered what your vertical movement is, and vertical movement still hasn't changed in that we always do exactly what it says to do. So if you look back at your exponential and logarithms, for example, which is the most recent functions that we studied, you'll see that it works in a similar fashion. Okay, so let's, before starting our brief sketching, let's take a look at what our parent function looks like. So due to our limited space, we're still taking notes way up here in the upper right hand corner. So let me zoom in here just to make it easier to see. So we're working in the upper right hand corner. So draw an x and y axis with me, coordinate plane. Okay. And our rational function is made up of these two sets of curves, one in the first quadrant, one in the second, sorry, not in the second quadrant, third quadrant. And the function's equation is f of x equals 1 over x. F of x equals 1 over x. Please note that our functions never intersect the x or the y axis. What that means is they have a vertical and a horizontal asymptote. The vertical asymptote is x equals 0, which is your y axis, and the horizontal asymptote is the y axis at y equals 0. So when your graph has its transformations, those asymptotes move along with those two curves, okay? All righty, so that's the basic parent function, all right? So let us see what happens when we start adding numbers and subtracting numbers to this function. What happens in multiplying? So let us take this basic knowledge and let's go apply it over here to problem number 1. Okay, so we're going to do number 1 together, and then I'm going to pause and have you do number 2 all on your own. Okay, so I'm going to hold your hand on this one. So here we have our function f of x equals -2 over x minus 3. Okay, so it's no longer 1 over x. Some stuff has happened to it. So let's talk first transformations. So looking at our horizontal movement, which is what happens in the denominator, that's down here. Notice that nothing is being added or subtracted to our x. So in this moment, there is no horizontal movement occurring. So we'll write no horizontal transformations or translations or whatever. I'll just put TRANS for translation. Okay, because there's no adding or subtracting occurring to the x value. Our vertical movement, as you guys wrote at the top, is always going to be the k value, the number adding and subtracting on the outside. Because it is negative, we can deduce that it's going down 3 units. Okay. So when you have determined what your horizontal and your vertical movement is, you are going to go ahead and draw your asymptotes, okay? So I know my initial parent function said that my horizontal asymptote is right here at y equals 0, right? But because there is no, sorry, horizontal translation causes, I'm having a momentary, okay, let me just start over. Your parent function has a horizontal asymptote at y equals 0, and it has a vertical asymptote at x equals 0. Because there was no horizontal transformation, but there is down 3 units transformation, that means those asymptotes are going to be affected, okay? So as far as our horizontal asymptote, because our function went down 3 units, that means our horizontal line also is going to go down 3 units, right? So we are going to come down here and draw a horizontal asymptote using a dashed line. And our vertical asymptote stayed at at x equals 0. I'm having a very rough time with my equations because it did not move left and right. Okay, so it stayed stagnant because there was no horizontal translation. The horizontal and the looking at the ruler that's vertical is playing with my brain. So I don't know if it's doing the same with you guys. But hopefully I didn't really mess that up for you guys. But does everybody understand how to draw these asymptotes based on my transformations? My very poor presentation there. Okay, so if I didn't completely mess you up, there you go. There's your translation. So once you guys draw it, come over here and you can go ahead and give me your equations. Okay, so my vertical asymptote goes through the x-axis at x equals 0. My horizontal asymptote is going through the y-axis at -3. So I write y equals -3. Okay. Now, look out for reflection opportunities, okay? If you see your function being multiplied by a negative sign, you are going to be reflecting your graph over the x-axis, okay? So what does that mean? All that means is, I'm going to shift this over a second. All that means is this parent function jumps over the x-axis. This curve right here will be graphed down here in the 4th quadrant. This curve right here will be graphed up here in the 2nd quadrant. So this one goes up, this one goes down. That's all the reflection means, okay? So the curves are just going to change sides. So keep that in mind as we get ready to sketch soon, okay? Once you've figured out both of these, you are going to go look for our holes. Now, for this section, holes are going to be none the entire time, okay? The reason I did include the feature still is because in the future, you will have both forms given to you, this form and then the one I'm going to be giving to you on Friday. You have to remember which one does not have holes, okay? And that's the form that won't have holes, okay? So on today's assignment, when you guys eventually do it, whenever you find the time, always no holes. Yes. Yes, there are gaps. And it involves the factoring, and you will see how to draw that. Yeah, so that's exactly what it is. There is a gap These will not have any. Finding x-intercepts. So finding x-intercepts means we must let y be 0, okay? So let y equal 0, putting a little reminder there. So we are going to set our equation up by substituting y to be 0, which is our f of x. So 0 equals -2 over x minus 3. And we're going to do some very simple solving of equations for x. So 0 equals -2 over x minus 3. So I need to move the 3 over to the left side by adding 3 on both sides. So I get 3 equals -2 over x. Now I need to move the -2 over. The -2 is in the numerator, and when it's in the numerator, it stays in the numerator, okay? I always do it this way because it's shorter, but if this confuses you, I'll show you what most students do. To me, it's just more work. I'm going to show you over here. Here's what most students do, but I wanted to show you the way I do it. So you usually take this x and you move it over to this side multiplying. That's a step. And then you divide by 3 on both sides just to end up where I did in one step. Okay, so if you're still more comfortable doing that way, have at it. But I just always do my little top goes to the top. Okay, does that make sense? So whatever works for you, both ways work. Okay, so there's our x-intercept. Let's go to x equals -2/3. You can't see what I'm writing. Let's go put a dot on the x-axis at -2/3. Okay, and so at that dot, I'm just going to curve to, wait, yeah, because it's a reflection, notice it's not going to be here and here. Okay, let me go back here. See, your parent function is here and here. Reflection means I'm going to put it here and here. So come over here, go from your x-intercept, curve towards, curve up. Don't lose sleep on this. Just give me some curves, okay? All right. Again, it's not on these quadrants because we reflected, so it's on this side. And our x-intercept pretty much tells us where to go because they're always across from one another, right? So far, we good? No problems. I don't see anything in the chat. Okay, looking up at the instructions, the next we are going to do is domain and range. Okay, so coming up here, I know we're running out of space, but if you write small enough, you'll be able to do it. So domain. Domain are what are the x values that are being used to graph these two curves. So if you guys look at these two curves, and when we do domain, we always regraph from left to right. So if I start way over here on the left-hand side and I trace my graph, notice I'm going left and all of a sudden I shoot up because it does want me to touch this wall that we call the vertical asymptote. But if we go on the other side of the wall, we start over here, we're going to the right, to the right, to the right, and we keep going forward. Okay, so what's happening is you are using all the x values, but they're saying, hey, you know that wall at x equals 0? Don't use it. Okay, so it's restricting us from using this x-axis, the x value, my bad. So what you're going to do as far as interval notation is you're going to say, start from the far left and keep going right. So far left means -infinity. Keep going right all the way to you get to 0. But I want you to jump over it. So you're going to tell the reader, hey, you need to put parentheses there because it's not included. Jump over it by putting union 0 and say after you've jumped over it, keep going all the way to positive infinity. That notation merely means all real numbers except 0, exclude 0. Okay, always parentheses. Range is the same description. Okay, notice range, you are going all the way up and all the way down except you hit a horizontal wall, which is your horizontal asymptote. So start all the way from the bottom. You always start with the low numbers. Go all the way to your horizontal asymptote of y equals -3 that we have right here, right? And skip over it. and go all the way up. Okay. All right, so are we okay with it so far? Okay, so go ahead and do number 2 on your own, okay? I want you to do number 2 on your own, and I'm gonna give you guys 4 minutes to complete it, okay? Set timer for 4 minutes. Okay, so any questions on this problem? We're doing okay? Okay, so you are going to notice that in the instructions, the following feature was not required, and that's because I forgot to include it. But it's a feature that you guys are very familiar with working with. So if you would, please write end behavior here, okay? I want you guys to continue working with that end behavior because it's so powerful, especially for those of you that have chosen to move into calculus, okay? All this is heavily used in calculus. Very good question. I love that you've asked that. Okay, so it depends how the question is phrased. If you are asked to find the end behavior traditionally, like looking, let's just look at it as, oh, by the way, remote students, just in case you didn't hear what David asked, he asked, does this have 2 end behaviors or 4? Okay, and so, you know, obviously the question he's asking has to do because there's 4 arrows, right? Traditionally, if you say end behavior, you want to look at the arrowhead on the far left and the far right. So end behavior is what we're talking about, and that would be these right here. But specifically in my dual class in pre-calc, in college algebra, I teach them, like you just wanted to say, David, before, I would tell them find the end behaviors, and then I would say find the end behaviors as you approach your asymptote, the vertical asymptote. So there is, if it just depends how it's phrased. If you just see end behavior, it will be these far left, far right. But there are questioning techniques that would ask you for these. Okay, so that was very perceptive of you. So looking at this one, right? So this one here is on our far left, right? So I'm going to circle it right here. We're going to write our end behavior. So in order for you to tell me which is the end behavior of this one, you have to tell me as x approaches the far left, which is negative infinity, right? So that tells me you're looking at the left one, okay? What is happening to the y values of this arrow? What do y'all? Good. So does it decrease forever? No? Okay. Okay, what's the restriction? -3. So in essence, it is going to decrease forever, right? But the restriction is you can't pass -3, right? So is it safe to say your y values get very close to -3 but never touch? So you would say y approaches -3, okay? Very good. So with the same manner, you look at the right-hand side and you guys are going to notice as x approaches the positive infinity or the right-hand side, you will notice that the same behavior occurs, okay? Oh, forgot my negative. Okay. Are we okay with end behavior? Okay. So if you would, go ahead and write the end behavior for number 2. And then we have one more problem to do. And if you guys have no questions, we are done. Okay. So write your end behavior for number 2, wherever you can find a space. I know it's very tight. So in this, Go ahead. Sure. Moving over.
As x approaches infinity, why is y -2? Oh, that one. Oh, okay.
You're good? Were you looking at this one?
Oh, yeah, the one above.
The one, okay. Yeah. So when I'm talking about, and look at the far left, far right. So these are the ones that David was talking about. If I wanted those, I would say the end behavior as they approach the vertical asymptote. Does that make sense? I would be more specific. Mhm. Good. Alrighty. Where am I going? All right, so this one right over here. You would look at this one and this one. Okay. So what would you guys write for this one? Anybody? All right, as x approaches negative infinity, y approaches -1, and then obviously the other one would be the same thing, right? But positive infinity. Very good, David. Okay, so if you are good there, one thing I want to point out, because you're going to see this in your homework, going back to this parent function, let me bring this to your attention. You won't always have x-intercepts, okay? And the reason is, for instance, for this particular problem, if I had asked you to find x-intercepts for a parent function, if I let y be 0, I'm going to have 0 equals 1 over x, right? If I have to solve for x, using the way I do it, the 1 goes above the 0, 1 divided by 0 equals x. Are you able to divide a number by x? Sorry. Are you able to divide a number by 0? No. What is that called when you divide by 0? Undefined. Excellent. So this is an undefined situation. So please note that you are able to have no x-intercepts, okay? I had a couple of questions, students were confused because they're like, I don't have an x-intercept, and they were concerned because they thought they had to. It is possible to have no x-intercepts, okay? So you could just write none. That's fine, okay? Just like you wrote holes, none, okay? All right, my last challenge problem for you is number 5. I'll give you, you guys seem to finish a lot faster, so I'm gonna give you 3.5 minutes. Do number 5. Let's make sure you are good to go so that I have peace of mind in releasing you. Okay, so here is number 5. All righty. Sorry I confused you guys if I put that wrong problem at the beginning. Okay, so here is the answer to number 5. So please check your work. Get my cursor out of the way. Oh, no such thing.
I thought that the other ones, like the vertical, vertical.
No, that's me totally making a mistake there, and nobody called me on last one, so thank you. You are absolutely right. So vertical asymptote here is this one, and it's going through the x-axis. So let me change this instead. Thank you so much. Thank you for not being afraid to correct. So horizontal asymptote is this one. It's going through the y at -2, and horizontal is going through the x-axis at x equals -2. Thank you so much, Maria. Okay. All right, so any questions or corrections, anything, clarifications? Everybody's silent. Okay. If we're good, here is what I want you to, before I lose you, hold on. Don't leave me just yet. Let me tell you what you all need to do.